This is Jeremy Clark of jeremybytes.com, and today we're going to do a tour of the Go language that's targeted at the C# developer. Now, I'm probably not going to use Go as my day-to-day language, but there are a lot of interesting features that will impact the way that I work with C#. So today we'll build a small application that makes multiple concurrent calls to a web service and then outputs the results. In doing this, we'll see a lot of the conventions and language features that are part of Go. You can get the code at GitHub, the link is below, and the GitHub repo has steps, and we'll be going through each of those steps individually. So that sounds good. Let's get started. So I have some completed code here, and if we say async and then add the flag no async, this is going to query a web service and bring up items. We can see they're coming up slowly one at a time, and that's because the web service has a 1-second delay built into it. But if we do this without that flag, it runs things concurrently. And so it actually makes all of those requests to the server at the same time, and then we get everything back. Now, what I like about Go is this is baked into the language. So we're going to build this little application and see a lot of the features in Go as we go, as well as some of the opinions that Go has. So if you go to GitHub, there's a link in the video notes here. There are 2 folders in there. There's an async folder, and that's the one we're going to be using for our code. And then there's a .NET Core People Service folder. And this contains a .NET Core service that we're going to be using. So to start this service, I've already navigated to that folder. So I've navigated to the .NET Core People Service folder and just typed in .NET Run, and that fires up the service. And we'll look at the elements of the service as we go. So to actually get started with Go, I'm going to navigate to the async folder and type in code main.go. And what this will do is it'll create a new file for me called main.go and open up Visual Studio Code. Now I am using Visual Studio Code as an editor. I found that it works really well, particularly if you have an extension installed, which is the Go extension. And this gives us linting as well as a lot of code completion and other cool features. What we'll find is Go is very opinionated about certain things, and this extension actually helps you with all of that. So let's go ahead and get started. So to start out with, if you're following along on the steps on GitHub, this is step number 1, where we're just going to create a little console application. And everything in Go is part of a package. So the package main is the one that we use for the entry point of our application, but we can have library packages and other things as well. We actually won't be looking at those today. And then the entry point for our application is a main function. And to do that, we type in func main, and then we'll have a set of empty parentheses for parameters, and then curly braces to enclose that. Go does have a C-style syntax, but it is opinionated about certain things. For example, the opening curly brace must go on the same line as the function name. So if you don't do that, then you will run into problems. So similar to how JavaScript can cause problems if you don't do that, Go actually enforces it, so you don't have to worry about it there. So I'm just going to create a function that will create an array of IDs. So we'll say func get IDs, and eventually we'll get this from the service. We'll just hard code it now. And then we'll type in IDs, and we'll do a slice of int. So a couple things about Go. The first set of parentheses are the parameters. And in this case, we have no parameters for this get IDs. And then after the parameters, we have the return values. Now, what's nice about Go is we can have more than one return value. So we'll see some multiple returns later on. And we can also name the return values. So in this case, our return value is named IDs. And so if we assign to that and return it, we can use that inside our function. Now, the type we have here is a slice of int. And what we can think about a slice as is a dynamic array. Now, there is a real array underneath it. I'm not going to go into the details there. But from a C# perspective, we can think about this as an array that doesn't have a particular size specified in this case, and we can add to it and it will hold everything that we need. So to do this, I'm just going to hard code some values. So we'll say IDs equals append IDs 2, and this runs the append function, which, as you can imagine, appends a value, and it will return the slice, the ID slice, so that we can basically reassign it to the variable. And we'll just do this a couple more times. So we'll add a 3 and a 4, and then we'll return that when we're done. So this is pretty straightforward at this point. We're basically just adding 3 values to a slice, which again is a dynamic array. And now we can use those to print them to our console. So we'll just call this getIDs and assign it to a local variable. So if you notice here, I have IDs : equals. Now, Go is strongly typed. However, there is a lot of type inference involved in this. And so what happens is when I say IDs : equals, this will create a variable of type a variable with the name IDs, and its type will be based on whatever we're assigning to it. So very similar to how the var keyword works in C#. If the compiler can figure out the type, we don't have to type it in. And if I hover over this IDs, actually, let me go ahead and save. Every time you save in Go, the linter and helper kind of helps us out a little bit here. You'll see I have red squigglies. I'll point out why in just a moment. But if I hover over IDs, we can see that the type is a slice of int. So it knows the type based on what we're assigning to it. Now you'll see I do have red squigglies, and there is an error message that says IDs declared but not used. Go is very opinionated when it comes to how things are declared. So if you declare something and don't use it, it's actually a compiler error. So that forces you to do one of two things: either remove it, or you might need a discard or something like that, and we'll see that a little bit later. Now what I want to do is I want to take this list of IDs and output it to the console. And for that, I'm going to use a print method. And this print method comes from a different package. So I actually need an import for this package. And I want to show you something that really frustrated me when I first started working with Go, because a lot of times if there's a lot of imports at the top, kind of like using statements in C#, I would say, okay, well, we need to import format, we need to import several other things. But here's the thing, watch what happens when I save this. The import statement went away. So that Go linter, the Go formatter, it actually will remove unused import statements. And it's very frustrating. Now, the good news is you don't have to type all of those up front. So if I were to type fmt.println, which is really what I want to get to, and then type in IDs, and then save, you'll see it adds the import for me automatically. So good news and bad news, but it is something to get used to. So as someone who used to type in a bunch of using statements at the top of my C# code, this took a little bit getting used to. But once I got it, I really enjoyed it, because now I don't even have to worry about the imports. I just know that I can use these libraries and they'll come in automatically. Now, all of the imports we're going to be using today are standard Go packages. So when you install Go, you end up with all of these and they go into the path on your machine. So it can find them automatically. So we won't be talking about building our own packages today, but this is how you do it. Now, there is one more thing I want to point out, and I actually missed it when I was talking about the get IDs. And that is capitalization is important in Go. So if you notice, my get ID starts with a lowercase letter. This means that this function is not exported. Now, if I had capitalized this with a capital G for get IDs, then it would be exported. So this is really kind of the difference between public and private if you're thinking about the C# world. So things that are capitalized are exported. They're visible to other packages. Otherwise, it's just visible within this main package that we have here. So capitalization is important. That's another thing that took me a little while to get used to. So we actually have enough for a little program here. Now, I know a lot of people like to use the debugger that's part of Visual Studio Code. I'm actually not comfortable with it because I seem to fight with it all the time. So I'm going to be building and running from the command line. So I'm going to go back to this folder, and if I just look at what's in here, I see I have a main.go file. And then if I do a go build, it's going to automatically build that main.go file. And now I have an executable. And notice the executable is async.exe. It named it after the folder that I'm in. And then if we just run that, then we'll see we get 2, 3, 4 out. And so this is our slice, again, our array of the 3 values. And the print method prints out a default format. And we'll be looking at what that default format means in just a little bit. Okay, so if you're following along at home, that's actually the contents of the step 1 file. And so we saw kind of the basics of how to set up a Go program. We need our package. We need our main function as the entry point. We note that we have to have the curly braces on the same line as our function name. And then we saw that we can actually do some, we can have named return types. Now, something about this named return value that we have is I don't actually have to type in this IDs, because what's happening here is I have something called IDs as a return value. So Go knows that if I just return from this function, it's going to return those named values, whether they're assigned to or not. So I might get a nil or an empty back, depending on what I have. So this is what's known as a bare return in the language. And if I save this, we can go back and do a build. And we can do a run, and we'll see we get the same results. So this bare return is something we can do if we have named return values. So yeah, that's something that's a little odd. And it may make your code easier to read or less easy to read, depending on the situation. Okay. So that's the end of our, first step if you're following along. Let's go on to the next step. And for this, I'm actually going to get these IDs out of our web service. So if I flip over to my browser, I have an endpoint here that's going to localhost port 9874 people/IDs. And this gives us the IDs of all of the people that are in our particular collection. So let's just go ahead and get those values out, and we'll see how to make a web service call. Now for this, I'm going to use another package, which is the HTTP package. And so we'll say http.get. And what I've found is that it's easier if you kind of save at this intermediate point, because at the top, you'll see it brought in the import net/http, and then we'll also get better little pop-up help once that package has been listed as the imports. And so we can see this takes a URL string as a parameter, and the return types are interesting because notice the return types are response and error. So this is actually returning 2 separate values for the return. And one of these is a pointer to a response. Go does have pointers. I'm really not going to be talking about pointers today because that's kind of fun in its own. But you can see that we have 2 values coming back, response and error. So first, let's go ahead and put in this URL. And in fact, I'm just going to copy and paste it because that's the easiest thing for me to do. And how do I get 2 values out? Well, similar to how we have the IDs down below on line 14, I can say response, comma, error, set equals to what's coming back from this. And again, if I save, we'll see we have red squigglies, and the red squigglies are, hey, you've got 2 things that are declared but not used. But again, if we hover over this, we can see this resp is a pointer to a response, and the error is in fact an error type. So it's good practice to make sure that errors are checked. So I'm just going to check that error object. So we'll say if error is not equal to nil, then we'll just return. And so what happens in this case is if there's a problem with this particular get call, so, maybe the server's not responding or the location actually doesn't exist, then error will be populated. And in this case, I'll just return immediately. Now, what will happen is we'll end up returning an empty slice. So we'll return that ID's value that's specified as the return value, but it will be empty. Now, later on, we'll look at error handling and we'll kind of add our own errors to this. But for now, this is how we'll handle this situation. Now, okay, we have the response. Now what do we do with it? Well, we really need to read the body of the response and then parse the JSON that's coming out. Okay, how do we do that? Well, there's another package we can do to read the body, and that's in the IOUtil. So if we say IOUtil read all response.body, and you can see I'm getting, full code completion here, which I really like. And again, I'll just go ahead and save that to bring in that package. And then if we look at what this read all is, we can see this is a function that takes an IO reader as a parameter, and it returns a slice of bytes and an error. So this is actually returning us a collection of bytes and an error object. Now, the interesting thing is IO reader is actually an interface type. And I'll talk a little bit more about interfaces later because the way interfaces work in Go is pretty cool. Now, if I look at body, this says that body is a read closer. And what this is really describing is it's kind of describing two of the interfaces that it satisfies. So it satisfies a read. So the IO reader will work for this read all, but it also is a closer. And what that means is that this has a close method on it, and we need to close this when we're done with it. So closing it is very important. So really, actually, take care of that in just a second. First, let's get the values out. So we can get the body out of this and the error and assign those. So another thing that's interesting about how this assignment works is, again, this colon equals will create a new object. So this body is in fact created, and it's a slice of bytes. And then error is actually the same error object that was created above. So this does not create a separate variable. This will just assign a new value to this error variable that we already have. Okay, so again, we'll go ahead and check this for null. So error not equal to nil. And we'll return. And again, closing the body is really important. So we'll say resp.body.close. And then if it is valid, then we're going to want to try to parse that JSON. So we have, basically an array of bytes. How do we get that into something that we can use? Because I really want an, array of int in this case. Well, there is a JSON package, which is good. And it has an unmarshal method on it. And again, let's go ahead and save this. And that will bring in the import statement. And then if we look at what this wants a byte array. That's convenient since we have that in our body. And then it also has, you'll see here, it says interface with empty curly braces. And what this is an empty interface, which means anything will match it. So that means we can put whatever we want in the second parameter and it will compile. We might get a runtime error if if it can't unmarshal it, but it will compile. So you can think of this as in the C# world, if you said, oh, well, one of these parameters is object. And that's actually safe in the C# world since everything inherits from object originally. Now, in this case, again, this empty interface just says anything matches this. So we'll go ahead and add the body. And then where we want this is in our IDs that return that we have. Now, I am going to have to do a little dereferencing here. And again, I won't get into pointers because, anyway, this isn't the place for it. But you will need to learn about pointers. I thought I had left those long behind when I did C++ programming many years ago, but they're back in Go, and for good reason, but it is something that can make things interesting. Now, again, I will need to make sure that I close the body in case things are successful. So you'll notice that I have a couple things here. So this resp.body.close is something that I want to do anytime, right? So this is something I want to happen whether there's an error, whether it's successful. Let's just make this work. Now, Go has this pretty cool thing, which is called defer. And when you defer a method, so I can say defer resp.body.close, if I can type. What this will do is it will run this close method basically when this getIDs method exits. And that's whether it exits successfully or whether it exits with an error. So when we defer a method, it will always get called. So again, kind of analogy from the C# world, you can kind of think of this as a finally. So whether there's an error or success, it will always happen. And so defer, I think, is really cool because we can put it anywhere in our code. It doesn't have to be at the bottom. I can put it, well, in this case, the response.body object needs to be there. So I can put it anywhere after I have that response object. So I can put it where I'm thinking about it. I don't have to necessarily go back later. So this actually gives us enough code to call our service and output it to the screen. Our main function is going to stay the same because it's the same IDs array that we had before, or excuse me, our array slice that we had before. And so just again, to review what we have here, we do an HTTP GET on that location. Then we read everything from the body of that method into a byte array. And then we use JSON.onMarshal to turn that byte array into a slice of integers. Okay, so that's all saved. Let's head back and do a go build. And then we'll run our async and we'll see we have our 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. Okay, yes, I realize that's not very exciting. But again, we've seen a couple additional things that we can learn about Go. Particularly, I think defer is really cool. Checking the error messages is also interesting. You'll notice there aren't exceptions here. We have error messages that are coming back. And so this, it's again, a different way of thinking. We're not throwing exceptions, we're looking for an error state. And so it's more of a process of the code of the things that we expect. Now, Go does have an equivalent of an exception in C#, and that is called panic. And so if we try to read past the end of an array, for example, we'll get a panic. And that's, I like that terminology because it really makes me think that this is something that's, something that shouldn't happen, right? And if it does, I don't know what to do. I'm just going to panic. So I like that terminology because exception kind of makes it sound like, oh, there's something out of the ordinary, but panic is like, ah. So we'll see more error handling as we go along. Okay, so again, if you're following along at home, that completes step 2, where we're making a web service call and getting some values back. So for the next one, what I want to do is actually get one of these person records back. Okay, so again, in our original program that I showed at the beginning, we were getting person records. And this is what a person record looks like. So you'll notice that I'm hitting localhost port 9874 people/3. So I'm passing in an ID. And this is giving me a person object that has a number of properties. And this is in, kind of standard JSON JavaScript object notation. So we have an ID property, a given name, a family name, a start date, a rating, and a format string. So what I want to do is somehow get this object into my Go application. I need this person object, and so I need a data structure to hold this. Now, Go does have structs in it where we can put collections of values, which is kind of cool. So we'll create another type called person, and this will be a struct. And then we can start putting in the values that we want. So I'm going to start with ID, and this is an integer type. And then we'll go given name, which is a string, family name, which is also a string, start date, which is a time. So I'm going to bring in the time package. And so a couple things interesting when I hit save here. So the first thing is it will add the import for the time package. And then notice that it lined up the types of my struct. I think that's kind of cool. Rating of int and a format string, which is a string. And again, when I save, it's going to line all of those types up. Now, normally when we're talking about deserializing something from JSON, it will match up based on the field names. And if the field names match, everything goes fine. If you do have something that's a little different, maybe you have something with an underscore in it that you want to remove or add, there are notations that you can make on your struct to say, hey, when you're deserializing this or serializing it, here's the field type you can use. So just be aware that that's out there. Now, one thing that is important here, and I messed this up the first time I was trying to do this, is you'll notice that all of my fields that I have inside this struct are capitalized. And again, capitalization is important in Go because that means they're visible to the outside world. So initially I did lowercase items here because I thought, oh, well, that matches exactly what's on the JSON string. So it'll deserialize fine. And I got nothing. I got empty objects back when I tried to unmarshal the JSON. And that's because it couldn't find those fields. Those are basically, private fields. So capitalization is important. I need to make these capital in order for them to be seen. And then again, with the opinionated nature of Go, here's another interesting thing I found. Because initially I kind of did, okay, well, let's do capital I, lowercase d for ID. And I get yellow squigglies. And it's like, this really should be both capitalized. So again, it's very opinionated about certain things. Okay, so now that we have the struct that we can put our data into, we can use the same process as we did to get the IDs to get the person value out. Now, I'm still going to type this through because there are a couple differences. So we'll do a func of get person, and this will take an ID of type int, and it will return a person. Actually, something I didn't point out earlier, when you're looking at the parameters that are coming in for a function, you'll notice that the name comes first and the type comes second. So again, that's backwards from how I'm used to in the C# world, and you will type that wrong several times. So in this case, I have a function that takes a parameter of type integer called ID, and then the return type is a person. Now, this is not a named one. So up above, we had on line 11, we had something called IDs. So we actually named our return value. In this case, I'm just saying it returns a person. I'm not going to name it in this instance. And if I only have one return item and it's not named, I don't need parentheses around it. Okay, so again, just a little bit of syntax there. So yeah, let's do a little copy paste because that's how I'm feeling today. Because this is pretty much the same for the get, except instead of this, our example had 3, but I really want the ID in here. Okay, well, how do I do that? Well, I do need to create a formatted string. Okay, so this is very similar to string.format in the C# world, but it's actually more akin to things that you'll see in C++ as far as the way the formatting options work. So instead of doing this, I'm going to create another variable because doing it in line is going to be a little interesting. And I'm going to create something called the URL, and I'm going to set this equal to a formatted string. So this is in the format package, and there's an sprintf. And we'll just paste this in. Now, what we'll see is there's the printf. We're actually using print line down in the bottom on line 41, which is a relative, but there is a printf, which will print a formatted string to the standard output, the console, in our case. And there's also an sprintf, and this will generate a string. And there's an fprintf, and that will output to a file. So you'll see that pattern kind of over and over again. So the way this works is we provide a string, and I'm going to put a %d here, and then the variables that fill, or the values that fill in for those formatting strings. So in this case, I'm using %d, and that's outputting a decimal. Okay, so for a number value, an integer, it's not going to have the decimal field in there. So if we pass a 3 integer into here, it'll just say people/3 as a string. And then we can have as many of these as we want. And we'll be looking at some of these format methods as we go. Okay, so now we can just pass that URL through. And then we'll do something similar, again, checking the errors. So if error is not equal to nil, we'll return, what do we return? I'm going to return an empty person struct. Okay, this might not be the best solution. And in fact, we'll see later on when we look at error handling, we'll see how we can be a little more explicit that something went wrong. But in this case, we'll just say, if something goes wrong, I'll give you an empty person back for now. And then I'll do the same thing as far as the defer response.body.close, like we did above. And now I'm going to do something a little bit different. So up on line 17, we actually read the values from the body into a byte array. And then on line 21, we took that byte array, passed it to the JSON unmarshal function. But there's another approach that we can take for this as well. And so we can say JSON.newDecoder, and this takes an IO reader as a parameter. And we saw earlier that response.body was in fact an IO reader, so we can pass that in. And then we can say .decode, and that will decode it into an object. And this will be similar to the, again, we have the empty interface, which is similar to what we saw with the unmarshal above. And we actually need something to decode this into. So I'm going to create a variable explicitly. So to create a variable, we use var to specify we're creating a variable, p, which is our variable name, and the type, which in this case is person. So we can declare a variable without assigning something to it. So this is just a different syntax for that. And then we'll say %p here to pass that through. And then we'll return p in this case. So very similar to how we got the IDs, we're getting an individual record using the people/ID endpoint. And we see a different way that we can deserialize the JSON using a new decoder. Okay, so let's go down to our main function and actually use this. Okay, so we've got our IDs. And since we might end up with an empty IDs function, I'm just going to do a quick if statement here. So I'll say if lang, which is a built-in length function of IDs, is greater than 0, then I would like you to do something. If it's 0, then don't do anything because you'll just cause problems. A couple things about if statements. Again, the opening curly brace goes on the same line. There are no parentheses around the condition. And then the curly braces are always required. Always required. Again, very opinionated, always required. We're not going to give you the option like we see in other languages. So in this case, I'll say p, and we'll set that equal to what comes back from the getPerson function. And I'm going to just do a single value right now. So I'm going to pass in IDs 0. So the 0 index of IDs, and then we'll print that out. Now for this, we'll use printf. And again, that's the formatted print statement that will go to our standard out, in this case, our console. And so we'll go get some quotes in here, %d:, %v, and then I'll put a new line in here. And we'll do the ID and the person. So just walking through this string, again, %d will output a number. So in this case, I'm pulling out the ID property and printing it out. The %v says print this in the standard format. So on line 48, when we print out the IDs, we don't specify a format. That's not a formatted string. It's just saying put this out there. And so it will use the default way to output, in that case, a slice of ints. In the situation we have here on line 52, it's going to output the person in its default format. So we should have enough code to do that. So let's flip back over, do a rebuild, and see what we come up with. Okay, and there's our record. So we can see the default format is just to print out all of the values. So we can see the ID, the given name, the family name, the start date, which is specific time. I'm not going to get into that. And then the last value there. Well, we have a rating, and then in this case, John Koenig's format string is blank. So the last one is actually an empty string. So this shows us how we can get data out and decode it in a different way and output it to the line. So that's the end of step 3. For step 4, we're actually going to get all of the records out, and we're going to learn a little bit about for statements. Okay, so for statements are interesting, or I should say for loops are interesting in Go because there's only one kind of loop in Go, and that's a for. So, in C# we've got the for, we've got a for each, we've got a while, a do while, all those crazy things, right? Nope, there's one in Go, which is a for. The nice thing is it basically handles everything. So let's just for over all of these IDs. And let's just do a traditional indexed statement to start with. So we'll say for I set equal to 0, I is less than length of IDs, and then I plus plus. Okay, so that should look familiar. And then we can take our middle bits from here and put them up here. I'll just get rid of this stuff at the bottom. And then instead of 0, we will use I for the indexer. Okay, so we'll go ahead and do that. And then now when we build and run, we'll see that we get all of the records back. And these are coming back one at a time because we are, getting the IDs one at a time. And again, because of the way this service is set up, there's a 1 second delay. And so that's why it takes 9 seconds for this to complete. Okay, so that's kind of interesting. We have a for loop with an indexer, but in C# I kind of got hooked on for each. And can you do that? And the answer is yes. Because instead of saying for I, we can actually say for I comma n set equal to range IDs. So when we do a range of IDs, that's similar to a for each. And this actually returns 2 different values. The first one, I, now this is going to be confusing because when I hover over it, it'll say int, is the indexer. So we could leave this code the same and say IDs I on line 51. But then the second one that comes out, in this case is also an int, is the actual value. Okay, so again, in C#, this is what comes out as part of the for each statement. So we get both an indexer back and the actual value. So we can use either one of those to get our data. Now, what happens when I save here? Well, an interesting thing happens because it'll say, hey, you're declaring this n, but you're not using it. Okay, great. What do I do? Well, and actually, I want to go the other way. I don't want to index into this IDs. I actually want to use the n value here. Okay, so we'll save it. And now I get a different error that says I is declared but not used. So what happens if I kind of have to declare a variable, right? This returns 2 values. I need the second one. So I need a way to say I want the second one, but not the first one. because I can't just leave this I in here. And Go has the idea of what they call a blank identifier. So in the C# world, we would call this a discard, and it's just an underscore. So that blank identifier is a placeholder, and it says, hey, you know what, this value is coming back, but I don't want it. And this way, we're not declaring a variable that is unused. And so again, this is good. It's very opinionated. Go does not want us to have unused things in our code, which again, from a maintenance standpoint, is brilliant. But now we have this blank identifier, and you can see the getPerson method is using the actual integer value that's coming back. So if we run this, or I'm sorry, build and run it, then what we'll see is we get exactly the same output that we had before. So this little segment is basically showing us that there's a couple different ways that we can deal with looping. And those couple different ways both include a for, because there's one loop type in the Go world. Okay, if you're following along at home, that is the end of step 4. Now for step 5, what I want to do is I want to fix the output. So again, our default output that we have is it's just printing out all of the values of our struct. And that's not really what I want. I'd rather do something based on the name, because that seems to make more sense. Now, rather than, creating a big format string here, what I'd rather do is I'd rather put something on my person struct that has that format in it. And this is where things get kind of interesting, because we start talking about interfaces. Now, when we talk about %v, that's actually looking for an interface method that's, on our type. And it's actually looking for something called string. And that's because this is part of what's known as the stringer interface. Let me just flip back to a browser, and I'm just going to type in golang fmt stringer. And this will take me to the programming language specifications, and I'm going to look at the stringer type. And this shows us what an interface looks like in the Go world. So we can see we have a type. The type is named stringer, and it is an interface. Now, in certain ways, this is similar to C# interfaces, because what it's saying is, hey, this interface has a method, or a function, I should say. This is one function, and it's called string. It takes no parameters, and it returns a string. So it's called uppercase string. Again, uppercase because it's exported, and we need to see it outside of the format package. Now, the interesting thing that varies quite a bit from C# is how we implement interfaces. Because in the Go world, I don't have to go to my person object and say, hey, my person implements stringer. I don't have to say that. All I have to do is implement the members. So if my person's type has a string method, takes no parameters and returns a string, it automatically implements that interface. It's called implicit implementation in the Go world, and it's pretty cool. Okay, so let's just use this type. So again, I have a func, which is called string and returns a string. Okay, takes no parameters, returns a string. Okay, but that's just the function itself. How do I associate this with the person type? Well, for that, I use what's known as a method receiver. And what that is something that goes before the function name, and it specifies this is the type that this belongs to. So in this case, I'm saying this belongs to the person struct, and it's a function called string. And since it has that P, it's a named method receiver, that means I can use that value inside of the method itself. Now I'm going to change change terminology a little bit, and that's the difference between a func and a method. So these are different things in the Go world. C#, we kind of use them interchangeably, even though there's some technical differences in terminology. But a func does not belong to anything. A method does belong to something. So in this case, this string is a method, and it belongs to our person type. So that's the difference. A method belongs to a type, a func does not. Okay, so let's just use sprintf format, sprintf function here to do a default output. And I'll just say %s, and %s is string, and we'll say p dot given name and p dot family name. Okay, and so, actually need to return that value. There we go. Okay, so if I return that string that's coming out of the sprintf, then we'll have given name space family name. And this is all I need to do. Again, I do not need to specify that the person struct implements the stringer interface or anything like that. It just has to have this method on it. And so now if we build and rerun our application, we'll see that we get our format out, which is given name space family name. Now we do have a small problem with this, and that is number 3, Leela Turanga is coming out wrong. That actually should be Turanga Leela, and that's a cultural thing. So in Leela's culture, the family name comes first and the given name comes separate, second, if you're doing a format such as this. Now, if I go back to, actually, let's go back to the endpoint here. I actually have number 3 in here, and we can see format string is populated for Leela. Now, there's some unfortunate stuff here, and that is that this format string, the curly braces, the 1 and 0, this is really designed for a C# format string, so it doesn't really work in the Go world. That's one of the implications of just lifting something from the C# world and saying, oh, well, anyone can call this. So unfortunately, this object is not designed well to be cross-language. So what we're going to do is we're just going to see if the format string is populated. So if the format string is not populated, we'll go ahead and use our default value. Otherwise, if it is, we'll do something else. So we'll say if p.formatString not equal to empty string, okay, something I tend to make a mistake of all the time is I put in nil here. And if you save it, it'll say, well, that's not going to happen because strings can't be nil. Their default value is empty. So if it's that, then we'll just say this is p.familyName, comma, p.givenname. And then I'll put an else statement in here. With the return, it's really not needed, but just to kind of show that this really is an if-else statement, we'll do this. And you'll notice, again, opening curly brace for the else is on the same line. Let's see. Okay, actually, this doesn't want me to do that, does it? If a block ends with a return statement, drop the else. Okay. The linter actually wants me to do it the other way. Oops, except I lost my curly brace. So we'll do what the linter says. I'll use the if else a little bit later. That's interesting. Okay, so my sample code is wrong. I'm going to have to go and update the GitHub project because I did not notice that little tiny yellow squiggly before. So there we go. And then now if we do that and we are saved, and we'll do a go build, and we'll run our async again. Now we see that Turanga Leela comes out appropriately, where we have the family name first and the given name second. So this showed us a couple of things. First of all, how to deal with default formats with the stringer interface. So if we just have that %v or even line 55, right, where we're just doing a print line and giving it a type, we can control what that default output is with the stringer interface. And to implement the interface, all we have to do is add a string method to our type. We don't have to explicitly say this implements this. And so what's interesting is the way interfaces are used in Go, they're kind of combined and A lot of the interfaces are very small, 1 or 2 methods, but sometimes they're combined to build things up, and you don't have to be explicit about it. You just say, hey, it has this capability, so it's automatically of that interface type. Okay, so again, if you're following along, that is step 5. And we're moving on to step 6. And for this, we're going to do a little bit of cleanup on our main function that we have. The first thing that I want to do is, because I'll say the next step is we're going to add the concurrent calls, right? So we're going to add the asynchronous calls to this project so that instead of calling each of these things one at a time, we can call them all at the same time, and hopefully it'll happen faster. Now, to do that, first thing, I want to set up a little time output so I can see how long each of these takes. At the top of my main function, I'm going to add a time. So we'll say start equals time.now. Okay, so that'll give me the current time. And then down here, after we do everything, I'm going to get the elapsed time. So elapsed set equal to time.since start. Now time.since will return us a duration type. So elapsed is actually a duration. And we'll just output this using printf. We'll say total time, %s, turn it into a string, and we'll say elapsed. And in fact, I'll add a new line there as well. Okay, so now if we build and run, we'll have one more piece of information once this is done. And again, we'll have to wait for those 9 seconds. And we'll end up with, hey, this thing took about 9 seconds. Now, one nice thing about using a duration object is it outputs in a format that makes sense for whatever duration it is. So in this case, it's on the order of seconds, so it comes out as seconds. If it's on the order of milliseconds, it'll show that. If it's on the order of minutes, it will show that. So that's an interesting way of how duration outputs itself. Now, the next thing I want to do as a piece of housekeeping is I actually want to add no async as a command line argument for this particular application. And that's because by default, I wanted to do the async one where it's doing things concurrently, but I want to still leave this functionality in here so I can compare the two. So I actually want to check a command line argument. And for this, we use the Args that's actually coming from the OS package. And so this is very similar to if you've ever gotten arguments off of the console. In the C# world, it's actually a parameter that's on the main method, so you can pull it out. This is actually something that comes from the OS package. So I can say if the length of os.args, and again, I'll go ahead and save to bring in that OS package, is greater than 1 and os.args 1 equals no async, then I would like you to do this code here. And I'm going to actually cut and paste it because then it takes care of, well, it almost took care of the indenting for me. So we'll go ahead and save that. Now you'll notice I'm checking to see if args is greater than 1, and that's because args 0, there's always 1, and that's actually the name of the executable itself. So, and you'll notice I'm looking at args 1, not args 0. So args 0 would be async.exe, the name of our program. And then args 1 will be, in our case, no async. So let's go ahead and see how this works by doing a build. And then I'm just going to run it without the flag. Now you'll notice it skipped that block of code, so it didn't actually call anything at all. And then we can see how our elapsed time outputs in this case. So you'll notice it's on the order of milliseconds now. So it's like, oh, well, this is 10.99 milliseconds. So that's how it's going to output, as opposed to just above that, or actually let's add the no async. And we'll see that the order changes to 9 seconds. And so again, the output of that duration shows that as well. So that's just kind of a cool little thing there. Okay, and that's all we have on step 6. Step 7, we're going to move on to using goroutines. Now, goroutines are pretty cool because this is something that's baked into the language that does concurrent programming. And I love that idea because, you know, async await is really cool in C# and task is a really cool object, but they are kind of tacked on to the language, whereas goroutines are like a core part of how Go works. In fact, they're called goroutines, and we'll see why in just a minute. Now, basically what happens is we kick off a goroutine and it will happen somewhere else. You know, we can think of a separate thread, although, you know, kind of like the C# world, we let the infrastructure take care of how threading works. We don't really worry about it. But then how do we communicate between our main application and this separate goroutine that we kicked off? Well, one way of doing that is through what's known as a channel. And a channel, you can kind of think of it as a thread-safe queue. And we'll see it in action. But basically what we can have is we can have that goroutine put a value into the channel. And then in our main application, we could read the value off of the channel. So let's go ahead and do that. And I'm going to do this by creating a wrapper function of the getPerson method. So let's go up to our getPerson method. And I'm going to call this getPersonChannel. I don't really like this name, but we're going with it just so we can distinguish these two. Now this will take 2 parameters, an ID, which is of type int, and then a channel, which I'll call ch. And then this is the syntax we'll use for this, and I'll explain this. So again, a channel is a way that we can communicate across these threads. And in this case, we're going to put something onto the channel. Now, when we create a channel, we do have to specify what you're allowed to put on there. And in this case, we're saying this is a channel that holds person types. Okay, so this, if we try to stick something else on this channel, we'll get a panic. Okay, so it's going to panic. Hey, I didn't expect that, right? Panic. So this is a channel that's expecting person objects. And then with this little arrow with the dash that's pointing to the chan type, this is saying that this is a unidirectional channel, meaning that inside of this function, I'm only going to be putting person objects onto the channel. I'm not going to be taking anything off. Now we can create a bidirectional channel and a unidirectional channel going the other way, but we're not going to worry about this. But what this specifies is that this function will only put things onto the channel. It will not pull things off of the channel. And this is as easy as saying, okay, well, I'm going to call the getPerson method, pass in the ID, and instead of returning that value, I'm going to put it onto the channel. So this is taking the output of the getPerson method and putting it onto the channel. And again, that'll be a person object that we can have going in there. So this just created something that we can call asynchronously really easily and pass it a channel. Let's actually use this. And for this, I am going to use an else statement. So let's put this back up here, else. So we check the args. If it's no async, then we do this first section. Otherwise, we're going to do it with the goroutines. Now, I do need a channel in order to call this getPersonChannel method. So I need to create one of those. So we'll say ch : equals, and there's a function in Go called make that we can use to make various things. So in this case, I can make a channel that works with person objects. And if I hover over the ch, again, this will show me it's a channel of person objects. And I have my error that it's declared but not used yet. That's fine. Make can also build other things. It can build map objects for us, and that's similar to a dictionary in the C# world. We can also use it to make slices for us. And again, we can think of that as a dynamic array. And I won't go into the details of slices. That's something you'll want to study because a slice is actually a view on an underlying array type. So it's actually pretty interesting, but a little more detail than I can get into today. But you can use make to create a slice. And so this will provide us a channel that we can use for our call. Okay, so I'm going to do a for, similar to I did above. So for blank comma n in range IDs. And instead of calling get person, we'll call get person channel, and we'll pass in the n and the channel. But instead of just calling this, I'm going to put a go in front of it. And this turns it into a go routine. So again, that's going to kick it off and not wait for it to complete. So in our case, since we have 9 calls to the web service, it's just going to kick all of those off really close together. And then they'll just run from there. Now, how do we get the value out, right? That's the next question. And what we do is we read from the channel. Now, this is going to be a little interesting because of the way this works, but we'll say for n, we're still going to loop through the range of IDs. And I'm going to pull something off of the channel. And just like using the arrow pointing at the channel, put something on, using the arrow pointing away from the channel, pull something off. And then we can use the same format string that we had above on that. And so what this will do is it will pull something off of the channel. Now, before talking about that, I need to look at the red the red squigglies we have on this range, right? So this is saying, oh, well, you're not using n, so you shouldn't do that. Okay, well, discard it. And it'll say, oh, you really shouldn't do that because this is an assignment operator and it's saying, hey, you're trying to assign something, but there's nothing there. And so this is where we find out we don't need to do this part. So we can just do for range of IDs, and this will loop based on the number of items that are inside this IDs slice that we have. So the reason I do this is because I want to call the go routine the same number of times I'm reading off the channel. This is important because reading off a channel that we have on line 74, that's a blocking operation, meaning if there's nothing on the channel that's ready to be read at that point, our application is going to stop processing right here and wait for it. So if I try to read, so if I put 5 values onto the channel and I try to read 6 IDs off the channel, that last one is just going to hang while it's waiting for that ID to come back. Now, I'll talk a little bit more about other ways that we can handle this once we look at error handling. But for now, it's important to know that reading from the channel is a blocking operation. And if you don't read the same number, you could end up with a problem. Now, there is another way to deal with this, and that is you can close a channel. So often what happens if you have something, let's say I'm streaming telemetry from some object that I'm working with. If I'm streaming things onto the channel, once I'm done, I can close the channel. And if I close the channel, then line 74 wouldn't be blocking. It would try to read something off. It'd say, oh, there's nothing to read. You're done. And in fact, you can get an error off of that to know that, hey, this channel's been closed. So if you try to read from a closed channel, then it doesn't block. It continues and moves forward, so there's no problem there. If you try to write to a closed channel, you're going to get a panic, okay? Now, the way this particular application is set up, it's really difficult because where would I close the channel? Well, I don't have a good place for that because I have this, I'm waiting this 1 second for things to come back where I'm writing things to the channel up here on line 39. I'm doing this multiple times, so I can't close it after each call. And then down here on, line 71, I can't really close it after the for loop because things aren't done putting things onto the channel yet. So this particular scenario is a little weird. So what I'm doing is I'm writing a certain number to the channel and I'm reading a certain number from the channel. And because of the way things are set up, this should always work. Okay, so based on this, I should have enough code for an asynchronous call. So let's give this a try. So we'll rebuild this. And the first thing I'll do is I'll call it with no async, just because I want to make sure I didn't break any existing code. Okay, that existing code is still working. I like that. And now let's call it so it runs asynchronously. And so we get a bunch of concurrent operations. And that's good. Look, our total time is different. So I went from 9.13 seconds to 1.02 seconds. So all 9 of those requests to the web server were made at basically the same time. And then the web server took 1 second to process each request, but sent them all back at the same time because we're making concurrent calls. Now you will notice that the numbers are not in the same order. And that's because once we start talking about parallel code, depending on how we're doing it, order is non-deterministic. So if I run this again, we'll actually see a different order. So both of these actually have Tarangalila as number 1, or the first item, I should say. But for the second item, we've got Isaac Gampu in the first call and Dante Montana in the second one. And again, if we do this again, we'll get a different order. So now Isaac Gampu is the first one to return. So the order that this is coming back is non-deterministic, and it will depend on the order things are put onto the channel. So that's going to depend on quite a few different things in our case. Okay, so for those of you following along at home, that is the end of step 7, where we use a goroutine and a channel to pass data back and forth between asynchronous method calls. Now, again, I'm someone who spends a lot of time with async code and parallel code, and so I find this idea very interesting, and I'm looking forward to exploring it further. So moving on to step 8, we're going to be looking at errors. And the first thing I want to do is add some actual error handling to this getIDs function that we created at first. Because if we look at the HTTP GET call that we have on line 13, that has data and an error that comes back. If we look on line 18 at the read all, that has data and an error that comes back. Well, that's a pretty regular pattern in the Go world. So instead of just returning empty values, I'd rather return an error object. And so I'm going to use that same format. Okay, so I'm going to create another return, which will be of type error, and we'll name it ERR, since everybody else names it that. So this will now return a collection, a slice of ints and an error object, and it will return each of those. Yeah, now you'll notice I get no red squigglies on here, and that's because my bare returns that I have on line 15, 20, and 23 all still work. So if IDs is empty, it'll return that. If IDs is populated, it'll return that. If errors is empty, it will return an empty error. And if errors is populated, it will return a populated error. So instead of using a bare return, I really want to be more explicit here so that we don't get into trouble. So instead, what I'll do is I'll say, okay, well, we'll return nil, which means that I'm going to have an empty value for my int slice, and then I'm going to return an error. Now, I could just return the ERR that's coming back, right? So this is the error that's coming back from the get method. But generally what we'll do is we'll append our own information onto it. So I'll use another method from the format package, which is errorf. And this lets us create a formatted string that specifies an error object. Okay, and in this case, I can put my own value, which is error fetching IDs, in this case, and then %v error. And so I'm prepending the existing error message with my own error message. Now, something that I learned about from reading is it's recommended that you use a lowercase start for your error message, and that's because this might get prepended by something else, prepended by something else, prepended by something else. So kind of your error, lowercase your error message colon, and then add on the rest of the error is a standard format for this. And we can actually use this same thing down here, except instead of fetching IDs, we'll say reading IDs, because this we're actually reading from the body. And you know what? It turns out this unmarshal also returns an error object. So let's go ahead and catch that. And then here we'll say that there's an error parsing IDs. Now here you'll notice that I get an error when I'm assigning to this error object that I have. And that's because it's saying there's no new variables on the left side. Again, that colon equals will create a variable of a particular type. In this case, we're reusing this ERR. So here I'm not creating the ERR variable. I'm just assigning to it. So I don't use the colon equals, I just use the equals. And so this changes the way that our getIDs method works. If I scroll down, we'll see that I've got some red squigglies down here. And on line 63, it says, hey, you need to deal with the other return values here. You don't just have one, you have two. Now I could say I can't be bothered and just use that blank identifier, and this would still work. However, it kind of defeats the purpose. So instead, what I'll do is I'll grab this, and if there is an error, we'll just do something else. So if it's not equal to nil, then we'll do a format printf, and I'll say get IDs failed. And I'll put a %v with a new line and error. Okay, so I'll output the error to the console, and then I want to abort the rest of my application. I want to stop here. Now there is on the OS package, there is an exit. So we can say exit and then pass in a 1, and basically any non-zero value means it exited with an error as opposed to exited successfully. Okay, so how do we test this? Well, the easiest way to test this is to stop our service. So I'm going to come here to where my service is running, hit Control-C, which will stop that .NET Core service. And then we'll do another build. And then we'll run. So here we can see our appended error message. Okay, so that first get IDs failed, that's something I added in the main method. Error fetching IDs is something I added in the get IDs method. And then the rest of it is the error that happened. So we can see it's trying to get this particular URL, and no connection could be made because the target machine actively refused it. So standard error message when that doesn't exist. Now there is another way that we can do this. There's actually a shortcut, which is part of the log package. And this is pretty interesting. So the log package has something called fatalf. And again, we'll save to bring in that log package. And I can actually use the same string on the inside of this. Again, it's going to do a formatted string. And this will output to the log, and you can actually control where the output goes. If you don't do anything, it'll go to standard out, which in this case is our console. And then we'll see one other thing that it does. So let's go ahead and build and rerun it. And when we use log, it prepends a date and time. So I can see exactly what time this error happened. And so that's the difference. And again, it will do the, exit, OS exit 1. So our console application exits with an error. So if we had this was part of a batch process and it was looking for success versus not, that would still show up correctly. So that's kind of the first pass at doing errors. And I'll go ahead and just remove that. If you go and look at the code, both of these formats are in here. I left the comments in for the GitHub project so that you can see the alternate ways of doing these things. And that actually ends step 8. So now we move on to step 9. And basically what we're going to do here is add error handling to our other method, our getPerson method. So let's run up here to getPerson and do pretty much the same thing. Now I do need to add an error object to my return, but because I have 2 return values, I need to put them in parentheses. I don't need to name them, so I can still have my unnamed return, but I do need to have parentheses around it since I have more than one. Now you'll notice when I save here, I do have red squigglies, and that's because I'm not specifying all of the types. So here, I could return nil and, make that happy. But again, kind of defeats the purpose. So again, we'll do our format with our error error fetching IDs. Oh, I'm sorry, error fetching person, I should say. %v, and then, whoa, error. Okay, did that very badly. Okay, that's a little better. Okay, error fetching person. Oh, it doesn't want me to end with a new line. So again, that was showing the opinionated. Error string should not be capitalized or end with punctuation or a new line. Okay, and you know what? I ended up with, oh, I didn't put new lines there, but I put a new line there, which is okay, because that's at the end. Okay, thought I made a mistake earlier. Apparently I did not. Okay, so no new lines on your errors because we're prepending to these all the time. And we would end up with potentially multiple periods, for example, if we did all of that. Okay, now there is something else that we can check, and I just want to, show how this works, is in addition to checking for an error, when we do an HTTP GET, we can also check the status code. So I can say if the response.status code is not equal to 200, then I want to do something else. So we'll return, again, that empty person object, and then a format error. And we'll say fetching URL %s returned status code %d, and then we'll pass in the URL and the response.status code. So this will give us a way that we can see the status code that comes back. So again, how you want to do this is up to you. Either one of these would work. Both kind of gives us the best view into things that might be going on. And then if we are doing this, we do need to be aware that decode returns an error. So we probably want to check that as well. So we'll set the error equal to this. And then we'll just do a little copy paste here since our message is almost the same. And then this would be error parsing person, since that's our JSON object that we're trying to parse. Now, I do need to have an error return down at the bottom as well, but I can just pass a nil to this on success. So on success, we're nil. Otherwise, we'll go ahead and process it. So pretty much the same thing that we saw with the get IDs. The one difference is that we are also doing a status code check on this particular one. And then our getPerson channel now has an issue because, again, getPerson returns 2 things rather than 1. So what if I were to do person error : equals to getPerson? Okay, and then on the channel we put a P. And then theoretically I could do something that says if error not equal to nil, then just return. So don't put anything on the channel, just return. So this is a valid way of doing things, but it's actually going to cause problems with the way that we're reading from the channel. Let's just go ahead and work with this. Yeah, and I'm just going to put a discard on this other one. We'll come back to that in just a second. Okay, so let's go ahead and restart our service here. And again, just a .NET run, we'll restart the service. And we'll do a build. And we'll do a run. And we see that we have a successful run here. Now, how do I fake this error? Because if I turn off the service, well, that means the get IDs isn't going to work. But I want the get IDs to work, but I don't want the get person to work. Well, I'm going to cheat it a little bit here. So down here in my Go routine, when I say get person channel, I'm going to say n times 5. And so it'll just take the ID values, multiply them by 5 before calling it. So some of those IDs are not going to be valid. So let's build and run that. And then this is where we'll see the problem that we have with our channel. So I ended up with one valid value, and that's because 1 times 5 is 5, which is a valid value. But you'll notice my application is hanging now. The rest of the calls failed because they were invalid. But the problem is that I'm still waiting on that channel for things to finish. So I still want to read 8 more values before my application will actually start. So I have to kill this manually with a Control-C and go back and rethink this. Now, there is something that we can use, which is known as a wait group. And I'm not going to use a wait group in this area just because it's a little more complicated than I want to get to for a tour of Go. I'll have a separate article about that later. But instead, what I'm going to do is just adjust the way that this works so that instead of checking the error, I'm just going to use that blank identifier. I'm going to ignore the error. And then in this case, it will put an empty person object onto the channel. So it'll put an empty object on rather than nothing. And so that means that putting the number of things I put onto the channel will match the number of things I'm trying to pull off the channel. And by doing that, we'll see my application works, but it's a little weird. So again, it needs a little bit more work in this particular area, but at least it runs, right? So I have a bunch of zeros. Those are all my empty ones. And then the one actual value that I get back from this. Okay, so let's go ahead and put this back to our normal number. And then let's deal with this other call. So let's actually check the error. And in this case, we'll say, well, if error is not equal to nil, then we'll do, those are parentheses. I need curly braces. We'll do a printf, and we'll print out the ID because I want to print out the ID of the one I'm trying to get. And then we'll print out the error message. So this way I'll be able to tell what ID was I trying to get and what's the error message that I got back. And then I can say continue. And continue works just like it does in C#. So it'll say, okay, stop processing the rest of this iteration of the for loop, go on to the next one. So it'll skip that last print statement on line 84 and keep going. There is also a break if we want to get out of the loop entirely, but we'll just go with this. And then to check the error, again, I'll do the times 5 that I did on the other example. And let's see what happens. And this time we'll need a no async. So we see we get the one valid one, which is Dave Lister, 1 times 5. But then we can see for the other ones, we are trying to fetch these other URLs, 10, 15, 20, 25, 30, 35, 40, 45, and they return status code 204. So we saw that the status code we got back is in fact not a 200. So we saw how that catches that error there. Okay, so let's just go ahead and put that back and make sure that this all works. So we'll do our go build, we'll do our no async, and we see we get our 9 values back very slowly. It takes about 9 seconds. And then we run it with our async code, and it takes a little over 1 second. So that's actually our tour of the Go language that I have set up for today. I realize it's kind of long. and I thank you for sticking it out with me. There are a lot of topics that we haven't touched on, but you can see, we wrote about 100 lines of code and we touched on quite a few topics that have to do with Go. Now, some other things that I would look at would include looking at packages and how they work, looking at closer at exports, really looking at the project structure, because that's, again, Go is pretty opinionated about where you put your files. We just barely touched on types and interfaces, so there's a lot there. I totally did not talk about pointers because pointers can get fun, but basically you have value types and reference types in Go like you do in C#, and reference types are pointers. So it points to a memory address and you can get the value from that address and things like that. And then I already mentioned the wait group. So the wait group would help us in this case. And again, I'm sure I'll do a separate article on that to show how we can have a more robust error checking with our Go channels. And then one other thing that's pretty common is for Go routines, rather than having them call separate methods like we have here. So on line 89, we're actually calling this separate getPersonChannel function. Rather than doing this, it's common to do an inline function with Go routines. And that gets fun because there are also closures, which are known as captured variables in C# and other things like that. So you actually kind of open up a whole new world and some more problems when you do that. So hopefully this tour of Go has given you a good introduction as far as some of the things that are available in the language. So I would recommend that you go look for something that's called a tour of Go. If you do a search for that, you're going to end up at tour.golang.org. And this is actually a good overview of the language and the various features. So you can go through this, do everything in your browser, and get an idea of how things work. So if you want to learn more, that's a good place to start. And there's tons of documentation out there. So thanks for hanging out with me. Again, feel free to check out the GitHub repo for all of the code samples, and I'll be writing some more articles as I go. And thanks for hanging out with me. See you next time.